Hello everyone, welcome back to my channel. I'm Vishit Ramesh and today in this video I'm going to be talking about the elementary data link protocols in computer networks. So let's get started. So first, what are the data link protocols? Protocols in the data link layer are designed so that this layer can perform its basics function, which is framing, error control and flow control. Framing is the process of dividing bit streams from physical layer into data frames whose size ranges from a few hundred to a few thousand bytes. Error control mechanisms deal with transmission errors and retransmission of corrupted and lost frames. Flow control regulates speed of delivery and so that a faster sender does not drown a slow receiver. Types of data link protocols. Data link protocols can be broadly divided into two categories, depending on whether the transmission channel is noiseless or noisy. In this figure, we can see that the data link protocol is divided into two categories, for noiseless channels and for noisy channels. In the noiseless channels, we have the simplex protocol, stop and wait protocol. For noisy channels, we have the stop and wait ARQ protocol, go back and ARQ protocol, and selective repeat ARQ protocol. For noiseless channels, so first we have the simplex protocol. Data are transmitted in one direction only. Both transmitting and receiving network layers are always ready. Processing time can be ignored, infinite buffer space is available. This thoroughly unrealistic protocol, which we will nickname Utopia, is simply to show the basic structure on which we will build. There is one direction of data transmission only from sender to receiver. Here, we assume the communication channel to be error-free and the receiver will infinitely quickly process the input. The sender pumps out the data onto the line as fast as it can. This protocol has two different procedures, a sender and a receiver. The only event type possible is frame arrival, that is the arrival of an undamaged frame. The sender pumps out the data in an infinite while loop as fast as it can. The loop body consists of three actions, and they are fetch a packet from the network layer, construct an outbound frame using the variable s, send the frame on its way. So at the sender side, the data link layer is the sender side waits for the network layer to send a data packet. On receiving the packet, it immediately processes it and sends it to the physical layer for transmission. At the receiver side, the data link layer in the receiver side waits for a frame to be available. When it is available, it immediately processes it and sends it to the network layer. So in this diagram, we can see the frames which are transmitted from the physical layer of the sender side, which is received by the physical layer of the receiver side. And in this diagram, we can see that there is only one frame transmitted, which is when the sender accepts a request, there is a frame sent, and there is only one frame which is being received by the receiver. And this process goes on. So next we have the stop and wait protocol. The stop and wait protocol is data link layer protocol for transmission of frames over noiseless channels. It provides unidirectional data transmission with flow control facilities but without error control facilities. This protocol takes into account the fact that the receiver has a finite processing speed. If data frames arrive at the receiver end at a rate which is greater than its rate of processing, frames will drop out. In order to avoid this, the sender receives an acknowledgement for each frame upon its arrival. The sender sends the next frame only when it has received a positive acknowledgement from the receiver that it is available for further data processing. So at the sender side, the data link layer in the sender side waits for the network layer for a data packet. It then checks whether it can send the frame. If it receives a positive notification from the physical layer, it makes frames out of the data and sends it. It then waits for an acknowledgement before sending the next frame. At the receiver side, the data link layer in the receiver side waits for a frame to arrive. When it arrives, the receiver processes it and delivers it to the network layer. It then sends an acknowledgement back to the sender. So in this example, we can see at the physical layer, the data which is transmitted from the network layer to the physical layer, the frame is sent to the receiver side where it acknowledges and processes it to the data to the network layer. Upon receiving, it sends back an acknowledgement back to the sender saying that it has received the frame and it is ready to accept another frame. In this figure, it's even more easily explained. The data packet is sent from a sender to the receiver. Upon receiving, it sends back an acknowledgement back to the sender that it is ready to receive another data packet. For noise channels. So first we have the stop and wait ARQ protocol. The stop and wait ARQ is one of the sliding window protocol strategies that is used where reliable order delivery of the data frames is required. The stop and wait ARQ is used for noisy channels or links, and it manages the flow and error control between the sender and the receiver. The stop and wait ARQ protocol sends a data frame and then waits for an acknowledgement or ACK from the receiver. The ACK means that the receiver has finally successfully received the data frame. After the sender receives the ACK from the receiver, it sends the next data frame. So there is a wait, and then the next data frame is transmitted to the name came to the stop and wait ARQ protocol. The stop and wait ARQ, both the sender and the receiver have windows of the same size, that is 1. So the sender sends a data frame or packet with sequence number 0. The receiver, after receiving the data frame, sends an acknowledgement with sequence number 1, the sequence number of the next expected data frame or packet. There is only a 1-bit sequence number that implies that both sender and receiver have a buffer for one frame or packet only. So in this example, we can see that A is the sender and B is the receiver. So first, the A sends a frame 0 to the receiver, and upon receiving sends an acknowledgement 1 to the sender. Upon receiving the acknowledgement, it sends the frame 1. Upon receiving the frame 1, if it does not receive, it sends back an acknowledgement 0, and then again it sends back the frame 0, so it is lost. So again, it retransmits the frame 0 and acknowledgement 1. Frame 1 is again retransmitted to side B, and again if acknowledgement 0 is again sent back, again it's lost. So again a retransmission takes place of frame 1. So next we have the go back and ARQ protocol. The go back and ARQ provides for sending multiple frames before receiving the acknowledgement for the first time. The frames are sequentially numbered and an infinite number of frames. The maximum number of frames that can be sent depends upon the size of the ascending window. If the acknowledgement of a frame is not received within an agreed upon period time, all frames starting from that frame are retransmitted. The size of the sending window determines the sequence number of the outbound frames. If the sequence number of the frames is an n-bit field, then the range of the sequence numbers that can be assigned is 0 to 2 to the power n minus 1. Consequently, the size of the sending window is 2 to the power n minus 1. Thus, in order to accommodate a sending window size of 2 to the power n minus 1, a n-bit sequence number is chosen. So in this example, we can see that the frames 0, 1, 2, 3 are all sent from the sender to the receiver. Now frames 0 and 1 are successfully received, and then the acknowledgement is sent back to the sender. And upon receiving, the 4th and 5th frame are retransmitted, and they all are discarded since 2 and 3 frame are not transmitted properly. So again, since 0 and 1 are transmitted, they both won't be transmitted again, and hence 2, 3 and 4 and 5 will be retransmitted again to the receiver. So next we have the selective repeat ARQ. It is also known as a sliding window protocol and used for error detection and control in the data link layer. In the selective repeat, the sender sends several frames specified by a window size even without the need to wait for individual acknowledgement from the receiver as in go back and ARQ. In selective repeat protocol, the retransmitted frame is received out of sequence. In selective repeat ARQ, only the lost or error frames are retransmitted, whereas correct frames are received and buffered. The receiver, while keeping track of sequence numbers, buffers the frames into memory and sends NAC for only frames which are missing or damaged. The sender will send /retransmit a packet for which NAC is received. So in this example, we can see there's a timer set for the frame 1. So the frame 0 is sent from the sender to the receiver, and acknowledgement 0 is sent back to frame 3, so which is the closure time for 0, and it sends the frame 3 back. So frame 1 sends, the receiver sends back an acknowledgement 1 to frame 4, and then frame 4 is sent to the receiver. Frame 2. Now see, the frame 2 is sent from the sender to the receiver, and the acknowledgement 2 is lost. So the frame either hasn't been transmitted, or the frame hasn't been transmitted properly to the receiver. So acknowledgement 2 is lost. So again, the timeout, and then again the frame 2 is sent back to the receiver, which then again sends back an acknowledgement to, and hence this process keeps on continuing since all the data packets are sent from the sender to the receiver. Thank you everyone for watching this video. I hope you like and share this video. Thank you.